Hello, we are the University at Buffalo Solar District Cup team, and we will be presenting our proposed PV system design for the City of Denver / Auraria Higher Education Center. Before we move on, we just want to take a moment to acknowledge and thank all of our team members who put in so much work over the past 2 semesters, as well as all of our team advisors and team mentors who helped us out along the way. And then lastly, a huge thank you to our sponsor, the UB Student Chapter for Engineers for a Sustainable World. Our team structure this year included weekly Zoom meetings, so our individual subgroups met at the beginning of the week, and then at the end of the week, we had a general meeting to provide any subgroup updates. The diagram to the right here just shows our workflow. So we began with a site analysis, then broke up into the individual subgroups, and then came together to come up with our final design. As mentioned before, our district use case is the City of Denver / Auraria Higher Education Center. So this map here just shows the Aurora side and the Denver side, and then these blue squares represent areas that were off limits for PV placement. For our site investigation, we did look into the master plans to ensure that we complied with the goals of our district. So on the Aurora side, we looked into the master plans for the Aurora Higher Education Center, as well as their Aurora Sustainable Campus program. And these are just some of the goals that they have for the future. As for the Denver side, we did have to look into a bit more. So we looked at the goals and upcoming renovations of the Colorado Convention Center, as well as the Denver Performing Arts Complex. And we also looked into the goals of the City of Denver as a whole. So we looked at their 80/50 climate action plan, as well as their 100% renewable electricity goal. And additionally, the state of Colorado did recently pass a bill mandating for statewide greenhouse gas emission reductions by 26% by 2025. Okay. So additionally, for our site investigation, we broke it up into several parts. So we had a site analysis, and the purpose of this was just to identify all the available locations for PV placement. And so for this, we looked at Google Earth images, we looked at the district use case profile, master plans, and structural drawings. We also conducted a utility evaluation. And then lastly, for satisfying customer needs, as mentioned before, we looked at the master plans, and then we also looked at the data provided to us about electricity demand. And now Anirudh will talk more about our proposed design.
Okay, so we are proposing a 1.8 megawatt system for the Auraria campus that will offset 3.2 gigawatt hour energy annually. It consists of 1.3 megawatt rooftop system, which are located on Science Building, North Classroom, Boulder Creek, and Cherry Creek. In addition, we do have 2 carport systems of size 540 kilowatt on Maple and Holy parking lots. This system will offset 1,640 metric tons of carbon emissions annually, and Auraria will reach from 18.5% to 25.7% reduction from the baseline model. Now let's go into our individual design. So the Science Building consumes the most energy on campus with roughly 11 gigawatt hour annually, and thus it was a must to build an on-site PV system on it. We built a 368 kilowatt system on Science Building that offsets roughly 5.8% of its consumption. In addition, we have built 175 kilowatt system on the North Classroom that will offset 5% of its annual consumption. Now, to satisfy the power demand of the southern part of the campus, we have built PV system on Boulder Creek and Cherry Creek. Boulder Creek will offset 22.6% of its consumption, and Cherry Creek will offset more than 54% of its annual consumption. Now let's talk about carport system. So our 540 kilowatt parking lot system will produce nearly 1 gigawatt hour energy annually, which can be transmitted to nearby buildings to satisfy the power demands. At last, on the Denver side, we have our largest system on Colorado Convention Center of a massive 1.3 megawatt in size. It will offset 1,180 metric tons of carbon emission annually, which is roughly equivalent of removing 250 plus cars from roads of Denver annually. Now let's talk about the impact of our system. So it is utmost necessary to analyze the impact of the system on existing grid. From this process, one can avoid and protect the system from thermal overloading, reverse power flow, power quality, and safety related issues. Adding a PV system can be rewarding as it can reduce carbon footprint by making the grid more efficient and with better power stability. It also makes grid more resilient, and it can be used to provide more ancillary services. For our voltage overloading issues, we have implemented smart inverters in our PV designs. Smart inverters are just like inverters with autonomous decision-making properties. It provides a stable voltage output. Adding a smart inverter did solve our OpenDSS code without any voltage override by implementing a volt function. And now Tio will talk about the financial aspect of our project.
Our main goal in our financial analysis was to ensure the customer gets a competitive PPA while keeping the investor IRR above the expected return of investment for a system of our size. For our financial analysis for Aurora Higher Education Campus, using our system inputs for our 1.8 megawatt system, we calculated the installed cost to be $3 million and our PPA price to be 3.5 cents per kilowatt hours. Our PPA price will ensure our customer is saving money on power initially. Our customer will save about $13,000 in the first year, and the net present value of the customer savings will be around $160,000 in 20 years. We decided to use REX because it positively affected our PPA price. And without REX, we'd have to double our PPA price and meet our IRR of 7.81%, and that's not a competitive deal. Our cash flow has a payback period of around 11 years with an internal rate of return of 7.81%. Our financial model covered weather by having conservative estimates by having a buffer capacity for harsh weather. In 2010, AHEC voted in a sustainability fee where the students paid $1 towards the school's projects. Now that fee is $5 in 2020. By increasing the fee to $15 for 1 year, the school can save 20% of the installed cost. If they decide to implement this fee to pay off the entire project, that will be possible by extending the fee for 5 years. For our financial analysis for the City of Denver, using our system inputs for our 1.3 megawatt system, we calculated the installed cost to be $2.4 million and our PPA price to be 4.7 cents per kilowatt hour. Our customers save $30,000 initially, and the money they're saving will grow each year. In 20 years, the net present value of the customer savings will be around $340,000. We also decided to use REX here. From our cumulative cash flow, we get a payback period of around 11 years again, with an internal rate of return of 7.73%. We decided not to use community solar here because Colorado has a 100% renewable energy goal by 2030, but the first step in their plan is to get city-owned buildings to 100% renewable energy by 2025. We decided to just provide power for the convention center, since we will not be able to fully offset the power usage in the convention center, and also due to the risk of customer turnover, which is often causality of failure in community solar gardens. Now Henriette will talk about our development plan.
So starting off with our building and site plan, we focused on ensuring compliance with the zoning ordinances, the master plans, and any potential building restrictions. So starting off with the zoning, this map in the top right corner here shows the zoning areas for a specific district. So the periwinkle area represents the campus educational / instruction zone. This covers the entire Auraria side. The red area represents the downtown theater district, and then the light green area represents the open space public parks zone. Fortunately, we didn't have many restrictions present due to zoning, except for the campus educational / instruction area, where they did have a requirement saying that any solar PV installations on roofs have to be flush mounted. Ours are not flush mounted, therefore we will need a zoning permit for this. And also for the open space public parks zone, we will need to request permission from the Department of Parks and Recreation for any structure that we would want to place there. Moving on to the master plans, as we mentioned before, we wanted to make sure that we complied with their goals, although we also had to make sure that we didn't clash with any of their future upcoming projects and renovations. So specifically for the Aurora Higher Education Center, they do have a few planned, and this image in the bottom right here shows, this is taken directly from the master plan, and it shows all of their future upcoming renovations and projects that will occur within the next 5 to 10 years. And so we actively try to avoid placing panels on the roofs of these buildings highlighted in blue, except if the proposed renovations will be occurring inside the building. And then lastly, for building restrictions, the Colorado Convention Center roof does have a few. First off being that they are currently doing renovations on a certain section of the roof. And then the second one being that the structural drawings of the Colorado Convention Center roof did reveal loading issues along the center line of the roof. Therefore, we did have to place the panels along the perimeter of the roof. And then the Aurora Library and Arts Building were off limits due to pre-existing solar array systems on the roofs. Moving on to the construction plan, here we focused on acquiring the necessary permits as well as accounting for any potential risks. And so for permitting, we will need an electrical and a zoning permit from the Denver Development Services. But before we can acquire those, we will need a structural review as well as a signed letter from a licensed structural engineer in the state of Colorado. And then moving on to potential risks, we considered glare, fire hazards, safety, and concerns of the community members. And then these are just the ways that we would resolve those risks. And then here we have a rough outline of our proposed timeline. So we've basically done the entire project definition and planning phase. So we would be moving on to the project approval and initiation phase, which does include acquiring those permits that we talked about, as well as hiring a solar installation company. The permitting will take about a month to complete. And then for hiring, we will be recommending Namaste Solar to install the solar PV systems because they have worked with the Auraria Higher Education Center previously. Afterwards, we will be moving on to construction. So we will begin on the Denver side with the Colorado Convention Center, and this will take about 2 months. And then on the Aurora side, the installations will take about 3 months. And afterwards, the last thing that will be needed to be done will be the interconnection, and that will take about 2 weeks.
So now let's talk about innovation and result. So after implementing our design, Auraria campus will reach 25.7% mark, and their goal is to reach 26% before the year 2025. Thus, our proposal will help campus by providing an early boost, and they can start working on that next 2030 goal, where they have to reach 50% where they have to reduce by 50%. As a result, the entire Auraria community will emerge as a leader in mitigating the global climate change. In addition, our proposal is financially viable for both our customer and investor with a user-friendly PPA and a good project IRR. And now Henriette will talk more about the innovation in the community engagement aspect.
So the underlying goals of our PV systems were to, of course, meet the energy demands as well as the goals of our specific district, as well as to maximize savings of the consumer. Although we also want to provide an engaging as well as educational experience for community members. So we do have a few things planned for that, one of which is a solar bike with an interactive display on the Aurora side. So this will allow any student or staff member or just anyone on the campus to go on the solar bike, pedal for a few minutes, and then the monitor will display their energy output and then compare it to how much our solar PVs are outputting. Second, we will have solar charging stations across the campus for any phones and other electronics, and they will also serve as a bike rack, which is really great for the Aurora Higher Education Center since they do want to expand their bike network. Additionally, we will have solar smart flowers on the Denver side in the open space behind the Denver Performing Arts Complex. And then finally, we do want to increase the amount of solar and renewable energy education available for students. So we will be creating a solar e-guide in partnership with the Aurora Sustainable Campus program.
So then I would like to thank you for giving us this opportunity and listening to our presentation.